All right, Wayne, can you hear me?
Yes, loud and
Good.
clear. Thanks, mate.
Good afternoon yet again. The truth is that for any members of the future audience who listen to this, Wayne and I were on this call before we began. So let's go full screen on this one. I have already remembered to record. I hope there's plenty of people that ever turn this video up and actually recognize what the device is. And I hear the cassette tapes are coming into vogue again, by the way.
Nice.
Yeah, such a things. All right. Hey, Wayne, thank you for joining me. If you don't make it interactive, I'll certainly ask you a lot of questions when you start presenting, or I won't. We'll see. If anybody ever pulls this video up, I do think that they're going to be wanting to skip all my bits and skip to yours, but I hope that's not the case. And so we're here to talk about a new product that Red Hat announced, which is we know it as ACM, but it really is its long name is Red Hat Advanced Cluster Management for Kubernetes. And there's a purpose behind us adding the for Kubernetes in this slide because it isn't really just about OpenShift. It's so much more. So what we're going to do is I will give an intro of what the product is and does and who it's aimed to, and then I will pass it on to good old Mr. Dovey. So Mr. Dovey, you can run a demo and show people that what I'm saying was all true.
Sounds great. Thanks.
Now, we had a hiccup in our first recording, so I hope you can now see my next slide, which should read Kubernetes adoption leads to multi-cluster.
Yeah, looks good.
Good-o. And this is an important slide because as I talk to my customers, and I'm sure you do too, we're finding that people begin, they put a toe in the water with a cluster that they build, and then they put the whole foot in the water, and then before they know it, they put the feet and the hands in the water and have multiple clusters that they want to manage. And there's plenty of reasons for this. Whether it's because they have data sovereignty issues, or they want to break multi-tenancy up, or they have an issue with disaster recovery and whatnot. In fact, what I'll do is I'll skip to the next slide and kind of discuss some of those use cases. But first of all, what are people worrying about when they start running? There is one word for this, when they start doing multi-cluster. There's a lot of challenges that happen when you start not only doing Kubernetes, because it's still complicated, but when you start doing it at scale and with multiple different multi-cluster deployments. So it's this, these questions are going through people's minds by now, and I will include myself in the list. How do I implement and manage multiple clusters? And when doing so, what are the right ways to deploy the clusters so that I can do it consistently across the board, no matter what I'm deploying and where I'm deploying it to? Then there's the security-minded people who care how we ensure what the security policies are, and what am I going to enforce them? How am I going to enforce them across all my clusters? And to me, something that's dear, because at the end of the day, we don't just play around with platform. The reality is we're doing this for applications. So how do I update and manage all my applications across all these clusters that I'm allowing to pop up everywhere? So, why is this happening? Why is multi-cluster happening? And depending on who you talk to, they'll come up with a different conversation. Now, interestingly, Wayne and I recently presented this to a customer who looked quickly at this slide, and he said, "Well, I've got other reasons why I'm doing it." So very quickly, you can see that even my 8 examples here are not that complete. But I guess when I prepared this, I was focusing in 4 cases in mind for one particular customer. And so the first question that they raised with me is, Daniel, we've had an issue when upgrading a cluster, and to be truthful, we didn't do the right thing when we hit the upgrade button, but the reality is that the cluster crashed. Luckily, it was a dev cluster, but it did have an application on it that we would have liked to have available at that point in time. So I figured, well, what better time to introduce a product like RHACM than this opportunity? So they had an issue around application availability, which kind of in a way became a disaster recovery conversation too, because they really wanted to have their app, if possible, in 2 different clusters. And I'm sure, Wayne, you're going to be able to show that today because I've seen some of the magical work that you do. But others are focusing, for example, and this customer was in how to reduce latency. And in their case, this is very simple. They have apps running in what you would classify as an on-prem deployment of Oracle, and they want to make sure that the clusters that will present some of the information in this database happens as quick as possible. So they want to co-locate clusters nearby the source of information. But at the same time, that that arrow to the bottom right also plays in their favor, because they'd be looking at how to address the escalating costs of egress of data, and by co-locating, obviously they're doing away with all those costs. There's a whole bunch of other reasons, but I think that with what I've exposed and seeing what's on this slide, you may come up with your own reasons as a listener as to other reasons for deploying clusters left, right, and center. And so I guess one of the things that came to my mind when I started listening to people at Red Hat and analyzing what was out in the industry is that the reality is that when you start building more and more clusters, I'll use this word first. When you start consuming more Kubernetes, you start deploying more clusters, what becomes impaired is your ability to consume. It's your ability to manage them, to install them, to set them up, and to present them, and in doing so, guaranteeing that they're good to go, they have the right policies, they have the right integration into identity, so on and so forth. So it does become an issue of having an ability to consume Kubernetes properly. And for this, there's a number of personas that really care about this ability and how you, present your ability to your organization. So the first persona is the typical people that have looked at Kubernetes, they've deployed it. Sometimes they've done the if you build it, they will come in their organization, and it just hasn't necessarily happened. But eventually it does, and so now they're looking at building multiple clusters, and they're thinking, how can I manage the life cycle of all of these things that I've deployed? And I want to be able to do it regardless of where they reside, in fact, what flavor it is, and I want to do it all through a single control plane. That is quickly the big mantra that comes into IT operations. Then you've got the people that actually care for finding the root cause of failed components, and doing this on an application that could be sprawled across multiple clusters can become an issue. And then again, if you care about monitoring the usage of your clusters across multiple clouds, well, then you're in the IT operations camp that's starting to get a bit worried about their ability to consume Kubernetes. So then moving on to the dream side of the equation, which is the people that care about the applications, typically your site reliability engineers and your DevOps personnel. And they're looking at essentially what is my application up to, and what happens if, for example, there is an issue with cluster health that compromises my application availability. And on a more day-to-day basis, DevOps engineers care about being able to self-provision environments for themselves. And in this day and age, it's coming to the point where they even care about being able to self-provision a cluster for their own automated testing. They also care about policies around having the right cluster with the right policies for capacity, for performance, for identity, and other things that are important. In fact, also too, the third key persona, which is Mr. SecOps. And Mr. SecOps doesn't really care so much about uptime. He doesn't really care so much about application. He just cares about making sure that the people out there that are using these applications, which may be the public, keep kind of stay away from causing harm to a backend. So in their minds, they want to ensure that all the clusters are truly compliant with all the policies that they define. And that's hard if you have a lot of clusters and no way to manage them centrally. They want to be able to set from the get-go consistent security policies across everything that gets deployed. And if there is a configuration drift, for example, or even a breaking policy, they want to get alerted so they can remediate it really, really quickly. And so this is where there's a few players in the industry that are looking at this problem, and obviously Red Hat's looked at that too. And we've come up with our own solution to the problem. Today, I try not to dive at all as to the source of what we're releasing. Let's just say that it came from one of the good things that we've seen from the relationship with our new parents from IBM. It's some work that came from IBM and into Red Hat, and Red Hat took the ball, open sourced everything, and turned it into a product. And obviously, that product is what we call now RHACM for short. So in essence, if you've heard me, if you stayed with me this long, the reality is we're really trying to solve three key problems. The one about having multiple clusters, managing their life cycle no matter where they are, trying to drive the proper governance across all these clusters through policies, avoiding risk and remaining compliant. And obviously, as I alluded early on, the most important thing is it's all about really the application. So how do I keep the application lifecycle in a truly managed state across wherever it may be? And so, since I've said in many times that it doesn't really matter where your clusters are and what type of clusters they are, I wanted to make sure that I brought to the table the things that we support today, and obviously the top of the list is OpenShift. So version 2.0, which was, I believe, released recently from RHACM, now supports the long-term release of OpenShift 3, which is 3.11, and it also supports the latter versions of OpenShift 4, namely 4.3, 4.4, and 4.5. And for anyone who's ever deployed it or heard of it, we actually also support OpenShift Kubernetes Engine. So the industry does think that these are all true Kubernetes distros, but there's others out there. So with that, I'll name that we support Amazon EKS, Google's GKE, Microsoft's AKS, and again, in true fashion and being good children, RHACM also supports IBM's flavors, which are Cloud Kubernetes Service, and also the Red Hat OpenShift Kubernetes Service. Now, they may differ as to what we're able to do with one or the other. For example, we can create clusters for OpenShift through and through, regardless of where it's running, but we're not able to do that across the other Kubernetes flavors. So in the case of all those others, you have to create them separately and then import them into RHACM. So, Wayne, at this point, I think that I'm probably showing a whole bunch of old slides for RHACM 1.0. So what I'll do is I'll pass it on to you because you're going to show the real thing running.
Yeah.
And it'll be a newer flavor. So if you're ready.
Yeah, for sure. Thanks, Daniel, for that. Cool. I'm just going to share my screen. And hopefully you can see the home screen of ACM. Can you see it all right?
Yep, perfect.
Okay, great. So yeah, as mentioned, from a high-level view, ACM is able to do quite a few functions, manage not only OpenShift clusters, but other instances and flavors. And I've set up a demo environment to kind of illustrate how that works in action. Essentially, the key screen that we're looking at now is the summary of all our clusters under management. And effectively, we're running two clusters in a data center and two in Amazon, as well as 3 applications, as you can see on the left there. And you can get a breakdown of the usage and distribution of the pods amongst the different providers. We also get a feel for what's happening on the compliance piece, as well as any kind of health status of the cluster. And in future versions, that's going to be improved going forward with integration to Prometheus and Thanos. So that's a federated version of Prometheus. So that's pretty exciting stuff. Cool. So on the next screen, we have the topology view. In the topology view, we've given a breakdown of all the clusters under management, as well as any kind of violations or policies that potentially might be of interest or an issue in the setup. You can see that there's links off to each of these where I can actually investigate what's going on. Further to that, I have a view of the application topology. So each of these applications can be linked off to view more information. And you can see it's a good summary of this that I presented. The next part is the policy piece. And for this setup, I've created 4 example policies, which will dive into the details of what they do and exactly how they kind of enforce or inform the policy management the cluster. Okay. So one of the crucial things about ACM that's really important is the actual management of cluster life cycles. So in this case, I'm able to do sort of a batch upgrade operation to all the OpenShift clusters under management. And you can see it gives me a recommended version that I can essentially move to. So that's automatically figured out by using the Cincinnati upgrade path feature from OpenShift. So that really simplifies the actual management and the upgrade decisions. And then, of course, I can just go ahead and click the upgrade, and it'll go away and do the upgrade piece. So all these clusters shown here are under management, and you'll see that this is dynamically provisioned from ACM. So I have access to the actual console, I have login details and all those bits of pieces of information. Of course, this is dynamically created, so as soon as this video ends, I'll tear this down, but you get the idea that you're able to store any kind of bits of information. Another critical thing for managing and deploying applications is the labeling functionality. And when you explore the application deployment piece, you'll understand what the labeling definitions mean and how they translate to an actual application deployment. Coming up in future versions is the ability to actually manage other providers. So at the moment, if I do a dynamic cluster creation, you'll see that I have access to Amazon GCP and Azure. Under Tech Preview is the bare metal option, but coming out in the November timeframe will be the ability to deploy dynamically to vSphere, VMware, and of course OpenStack. So that's going to be really useful to have multiple deployment options. And as you can see, if I'm going through this sort of self-service capability, I'm presented with a YAML on the right-hand side, and that details bits of information. So of course, this artifact can be downloaded and replayed offline in the CLI method. So we don't have to use the UI, but of course, this is great for us to, in a development capacity, to understand what we're deploying to using the service. So going into the application side of things, I have 3 example applications. And as you can see, the first one called Bad Developer. The idea with the bad developer is to illustrate what would happen if there's a vulnerability that's been deployed into the clusters, and how does ACM handle that. So essentially, this ties into the next section on the policy management, and I'll discuss it a bit further. But just bear in mind that what's the method of how we manage vulnerabilities, and how do we remediate that. I'll definitely come back to that. The other application that I want to talk about is the blue-green deployment that's been done. So this kind of illustrates a simple application, and as you can see, these are the various components used to deploy the application. It's pretty straightforward, but essentially you have what's known as a placement rule, and in the placement rule, you'll see there's a thing called a cluster selector. And as I mentioned earlier on about the labeling, each cluster gets a label, and that would using these placement rules, that would determine which cluster that would be available on. So of course I can change this and dynamically set this up, and it can be as examples could be, I'd like to deploy to the development environment, and I'd like to deploy to Amazon. So that way you can have like a front-end, back-end setup, and there's quite a few good examples on how that works and how we can dynamically deploy things. So in this example application that I have deployed, we have like a sample application that's running here, and you can see that it's got a blue version 1 on both of the clusters. You'll see there's different URLs. What I'm going to do, I'm going to modify the actual code in here and make sure I'm in the right part. So under resources piece, I will modify that deployment. So this is a well-known artifact. That's the deployment artifact that I think you've all seen before. And I'm going to update this to version 2. So a simple operation just to illustrate, how we can do kind of continuous deployment, potentially blue-green setup, and how that works within ACM. So that's now been committed, and I'm going to go off to have a look at the pods in question on the namespace. And after a short amount of time, you will see that it'll trigger an update through the deployment for the service. And effectively, so you can see on the Tokyo cluster, now it's triggered that update. And it's a rolling update, so it'll take a little bit of time to bring into service the new pods. And then once that's completed, you'll see that if I go onto the Tokyo, it should be V2 as expected. So simple sort of illustration of how this is working in action. You can see it's awesome. It's a rolling upgrade. So then it's going to do the Sydney one, and then same sort of process of bringing on the service updating. Now this sort of stuff wasn't really possible before the product. It was a very hard thing to achieve, but you can see how simple it is to create those labels, placement rules, use well-known artifacts, and deploy an application quite simply. So it worked pretty well. Seems that the demo gods are smiling on us. Good.
That's really powerful, Wayne.
Awesome. Thanks, mate. So moving on to the compliance and risk piece, I think this is probably one of the most attractive and one of the most important parts of the product. Not to say that the application deployment stuff isn't, but I think there's definitely a massive requirement, and I would say a gap in the market to manage this capability on Kubernetes. I don't think it quite exists in the format that ACM delivers it. So for the basic example I'm showing, there's 4 policies that I've created. The first policy I'm going to talk about is the image vulnerability piece. Effectively, what that is, the image vulnerability has deployed an operator onto the cluster. And the function of the operator is to pick up any kind of vulnerabilities as far as image scans that have been done on the cluster and violations that have been detected. So you can see in this example, both clusters have that bad developer namespace deployed, and it's triggering a violation. And then, of course, this is set in the force policy. So that means it will deploy the actual operator, and it'll pick up an issue. So if I go over to the cluster itself and I look in the administration console, you can see it's reflecting the image vulnerability. So that way, people managing this cluster know, hang on a sec, we have a problem. We've got a vulnerable namespace, and they can do the actual necessaries to find out where this problem namespace exists, what the actual vulnerabilities are, and the opportunity to find remediation through fixed versions. So in this example, it's quite an old version of Java, as you can patching that. So really showing the power of not only the capability of patching stuff, but this whole ecosystem working together, which is very useful.
So was that through the use of Red Hat Quay and Claire?
Yeah, that's correct. So if you look at the operators, and I go installed operators, it brings up the Quay container security provider. So that's really nice and easy to implement.
As you say, it's interesting because you are covering a lot of ground with the integration of a lot of products that add a lot of value together.
Yeah, absolutely. And I think one of the things which I don't have an example of now, but there's an opportunity to manage operators more widely. So there might be a requirement to enforce something like service mesh. And using ACM, you can actually make sure that service mesh is deployed to every single cluster, which is really good. The next example is configuration management. So there might be a situation where you need to manage time-related configuration. In this case, it's Crony, also known as NTP, and you're able to then implement an actual capability around this. And what it does is it will enforce this policy on a machine config. And here's an example of the output. A great way to get configuration management working. Another example I'd like to illustrate is the use of network policies. So typically network policy is quite hard to manage, to implement, to enforce. This policy here is actually creating the network policy using the templates being provided. And it's a real nice way to ensure that network policy is enforced cluster and organization wide. So that way, you can ensure that you have an implicit denial policy that's been adhered to, and if there's any exceptions, of course, that could be added to this policy for people using the cluster. And the last one is around cluster upgrade. This is to ensure that your clusters under management are at a certain version. That really helps with ensuring that there's accountability around patching and releasing and sort of that life cycle. So in this case, we've set a desired version to be of 4.5.2, and in this case, we just want it to be in the form. And of course, if we wanted to, we'd probably, for maybe our dev clusters, we could make that enforced, and that would automatically put those dev clusters into that version required. And with over-the-air updates, that's pretty amazing stuff.
Now, would like I always tend to do and throw someone under the bus, is that upgrade something you could do if you were running, say, EKS2 or?
So I think that's it's a good question. I don't think so, but I mean, to add to that, any of those kind of non-OpenShift capabilities or requirements, this is the reason we in version 2.1, which is coming in November, they're looking at extending that capability with Ansible, and Ansible is going to be doing like pre-post hooks to do actions around any of these requirements. So if it's like application management, there'll be like actions that Ansible provides. If it's policy management, Ansible will be doing that. So yeah, it's quite rich what it's able to offer. But of course, I'm still waiting to see what that looks like in November.
Well, we'll cut another video then.
Absolutely. So just to go back to the standards thing. So you're able to implement an actual policy and standard. And you can see in this example, we've got NIST, which is I think it's the US government policy. But of course, you can create a policy based on something like PCI, which is quite more widely used, and CIS, for instance. So this has been worked on all the time, and out of the box, you get quite a few options that are available to help you actually build it up. But added to that, we have a whole kind of library of those policies, which quite a few of our Red Hat people have been working on. And yes, that's me. Hopefully enjoyed that.
That was very good.
Awesome. Thank you.
Well, if the audience has no questions, then we might have to cut it here. So thank you for that, Wayne. What I'll do is I'll stop the recording now, and so give me a second. Thank you, everybody. If you listen to this point, Wayne and I truly appreciate it. Hopefully we'll get more than 50 hits at some point. Stopping the recording.